Okay, so today I did a acid-base titration with my Chem 30s just to practice all the titrations we will be doing this semester. While I was doing it, the question was, what is the molar concentration of a sample of HCl? So that's what we want. I have, following the procedure for titrations as explained on the video, it does say the next slide, but I will add it in on the end. And then when we are doing this, the base is going to go into the burette and we know the concentration. We are also going to take 10 mils using a pipette of the acid, the one we're finding the concentration of, and adding in an indicator. Now at the start of the titration, your acid will have a yellow color. And then if you pass the titration, it will be very blue. A perfect titration in this case with bromothymol blue as indicator would be this green color. So that's what we want us to see. And I just took a picture of one of the students' results today. So they used quite a bit of indicator. That's why it's pretty dark, but it's still that green color. It's not yellow and it's not blue. So that's a great color to see. So again, I'm going to link the video, but when we're looking at the trials, just filling in some information here. If I start with my first trial, I had initial burette reading of 0, and when I was done my first trial, it was 15.1. So with this one, my total volume used was 15.1 milliliters, and my endpoint color was a green color. Now, for a titration, you should do a minimum of 3 trials. I'm just, for the point of this, going to keep going. This was the analysis I gave them in class, where they had to calculate the average volume. So taking a look at what we had to keep, we talked about how if you had one that was really, really blue, you probably past that endpoint, so say we had a lot higher, we wouldn't want to include that in our calculation. So you try and keep the values within 0.2 of each other, but at the same time, what I was mentioning to my students is use the trials that you knew were good. So even if, say, you had another one that was 16.7 and you got that blue color, even though these ones are closer together, still not within 0.2 of each other, we wouldn't keep these ones because the green color was our best one, which would give us the best results. Now, the next part was to write the balanced chemical equation. So for mine, I'm not going to use an average because I only did it once. So my volume would be 15.1 milliliters. Looking at my balanced chemical equation, I would have my acid reacting with the base to give you your salt, which is NaCl, and water. Now this reaction is all 1-to-1, so we don't need to add in any coefficients. And then to show our calculation, we are going to start with the base, but turn it into, so divide this by 1,000 into liters. So we'd have 0.015 liters of the base and AOH, and we're going to multiply it by the concentration of the base, which was given to us in the procedure, and I had it on the second slide that we looked at. And so this is moles of NaOH per 1 liter, so liters cancel. Our next step, now that we're at moles of our known, is turn it into moles of our unknown. And so even though in terms of the math, this doesn't do anything because it's 1 divided by 1, it does change your units, so we still want to see it. And then lastly, and students often forget this part, you want to divide by the amount of acid you used, and you are titrating 0.01 liters, right, 10 mils in each titration. So we do this, and I'm getting my answer of my concentration being 0.151 moles per liter. Now, a lot of the times when we're looking at any experiment, we are calculating percent error. And if you're looking at your percent error, it is the formula actual minus theoretical divided by theoretical. You take the absolute value of this times 100. So I'm just going to fill that in. My actual is what I get into the lab. So this value here, so 0.151, and that would be taken away from theoretical, or theoretical is taken away from that, which is 0.150, which I see here. This has to be given to you. And then we're going to divide by 0.150. Now, once you're done, multiply this by 100, I believe my percent error was really small, like 0.06 repeating. So that's great. I'm going to just write that down because it shows that we were pretty accurate. And the other conversation we had today was about percent error because it tells you how wrong your experiment is. The closer to zero, the better. So that was about it. I'm now going to just link in the video that has the explanation of how to do the titration and has an actual demo of the titration. And it will also show where I'm getting these values from in my calculation. Up until now, if you're just watching up until this point just to see how the analysis worked, thank you for watching. If you do find this helpful, please subscribe. And I think that's about it. Now I'll link up the video. Thanks for watching. Okay, so I'm setting up for my titration. I'm putting the funnel on top of the burette, and I need to clean up my burette. So to do that, I am going to make sure my stopper is on. I know that because it's horizontal. I'm sorry, not on. I want it to be open so it runs through. So I am going to flush my burette with water, just some distilled water, and that will go through. And then I want to flush my burette with what's going in it, which is the base. So I'm just going to flush that. And then once that's going through, I can be sure that it's clean, and I will put the stopper on, and now I will fill the burette to the 0 mark with the base, the NaOH. Now, once I'm done that, I'm going to grab the Erlenmeyer flask with the pipette, and I'm going to pipette 10 mils of the acid, which is coming up next, into the Erlenmeyer flask. So I am grabbing my acid, grabbing the pipette, and pipetting is a skill that we want to be good at if you're moving on in chemistry. We have older pipettes at my school, so I squeeze the pipette bulb, let that liquid, that acid come up, and then I'll have to squeeze it one more time so that I can get to the line that indicates 10 mils. Now, once I've done that, I'll transfer it into the Erlenmeyer flask. And then I have to add the indicator. I'm using bromothymol blue, which is yellow in an acid and blue in a base. If I do my titration perfectly, I will get that nice green color. So now my acid is in the Erlenmeyer flask. I'm adding in a moment, the bromothymol blue, and I'll watch my solution turn yellow. And you don't need a lot, just a few drops. If you have a little bit, it will be a light yellow. If you have a lot more, it will be a darker yellow. Now I like to titrate with a white surface, so I am just grabbing a white board to stick under my Erlenmeyer flask. Now I'm ready to begin. So technically in a titration, you should go drop by drop, but that can take a while. So trial 1 usually gets thrown out and it just gets you to the area you need to be, and you can be careful, more careful in trial 2 and 3. So in my first trial, I know I'm getting closer to my endpoint when that blue color that's appearing sticks around. So like right now it's sticking around a little bit more. This would be a good point to go drop by drop. But of course, because I'm doing a demo and getting distracted, I'm going to go a little bit faster. And what always happens is I pass my endpoint. So right before I got that blue color, I was around 15.1 milliliters, and I was able to use that in my calculation.